Okay, so welcome once again, right, to the first session of week 6 of the Cairo Bootcamp 4. So we have successfully made it to week 6. From week 1, we've gone through the basics of Starknet, Cairo, data structures, um, advanced concepts in Cairo, which was taken last week. And today, I mean this week, for the rest of this week, we're going to be learning how to test our smart contract, right? How to write tests for our smart contract. So our tutor, Coding Cast, will be taking us through the fundamentals of smart contract testing on Starknet, and is also going to be walking us through like a hands-on on how to test um, for an ERC20 smart contract. And I think you also have other plans, right, of writing other smart contracts as well, like testing other smart contracts as well. So as usual, if you have any questions, always ensure you drop them in the chat box. You always check the chat box from time to time, right? And if you have any concerns, any complaints at all, as regards the management or anything at all, you can always also drop your questions, your complaints in the chat box, or wait till the end of the session. I'm going to take any questions you have. Okay, so I'm going to be handing over to our mentor now. And I don't know, last week, your mentor had a bounty of $50 and nobody got it. So I don't know whether he still has the bounty available. So in case maybe the spirit is ministering to him. So just make sure you're engaging as much as possible, right? Casweeney, you can take over, please.
Hi everyone, GM. How are you doing? How are y'all doing? Um, okay. I hope you had a wonderful weekend. So I just want to do a status check. How was the last class? Hope you guys were able to do the assignment and some of those of you that read the article, hope you got value, you were able to understand some of the things you didn't understand. Yeah, please just make use of the chat box. If you're able to do your assignments, let me see. Just respond that you did the assignment. If you went through the article, let me see your response. Um, if you understand everything we did in the last class, write it in the chat box. Let me see what's up. That I'm able to okay, check. I don't know. What's check? Do you understand what was done in the last class? Did you read the article? Have you done your assignment? Like, let me know what's up. Okay, okay. All right, that's good. Still on the assignment, had to rewatch the video on YouTube. Okay, good. Better clarity after reading the article and replaying the last session. Great. That's good. Understood the video, read the article, not done assignments. Okay? Yeah. The deadline is tomorrow, right? So you have you have till maybe I don't know when they are closing it, the time they are closing it tomorrow. Yeah, but you have till that time to do the assignment and all. All right. So um today we are going to be looking into testing, and we are going to write some cool tests. Like I told you guys, I've never used SNcast. I've never used it. I don't even know how to use it. So I know SNcast is used to interact with your smart contract and all of that, and all. So I've never used it. So what I do basically is after writing my smart contract, I I test it thoroughly using tests. Everything I want the smart contract to do, how I want it to behave, I make sure I test it and expect it to behave that way before I deploy. So when I deploy, man, I mostly deploy on test nets, right? So deploy on test net, also like interact with it using those scans, Stack scan or Voyager. I interact with it just to consolidate my test before deploying on mainnet. So that's my flow. So I am very big on test. And just to hint you guys, one of the reasons why so after learning Cairo and all of that, I decided to test out building or contributing to open source projects on Only Dust via OG Hacks. So as at then, a lot of persons were running from test issues. And it was those test issues that I liked the more. Because for you to write tests for any smart contract, you have to understand the smart contract first. So what I do, I apply for those issues, I get assigned, I'll just read the contract and I write the test. So testing was one of the things I love doing the most. It's very sweet. Like it's very fun to test. And when you write smart contract and your code is compiling, you feel happy. But when you write your test and your tests are passing, the feeling is it's more than the feeling you got when your code was compiling. You feel so good, like you have this confidence that everything is working very well. So yeah, I'm very big on testing. So without any further ado, let's get to business. I'm gonna share my screen now. Yep. All right. Can you see my screen? Please let me know if you see my screen. All right, all right. Okay. So let me show this guy. Okay, so today's class, we are looking into testing in Starknet, and session one is about fundamentals of smart contract testing, right? This is me. This is me. So this is what we are going to be looking at today. What is testing? Some of you might have been writing tests, but you don't really know what testing is. We are going to look at what testing is. We are going to look at categories of testing. We are going to look at why testing. Why do you test? Why do you have to test a smart contract? We are going to look at the tools for testing on Starknet. Then we are going to go into live coding where we do proof of work. I'm not very big on plenty talk. I'm big on, actions, writing the codes. So we are going to, you must have heard that there's a difference between a Cairo program and a Starknet smart contract. So we are going to see how to test the Cairo program. We are also going to test a very simple smart contract, which is a setter-getter contract. The reason why I'm going through this route is so that I start from the lowest level. I don't just go into testing complex smart contracts. I start from testing simple things so that you're able to understand it from like ABC before we start dealing into the complex stuff. In school, when they were teaching you mathematics, they'll teach you things like 1 plus 1. From 1 plus 1, they teach you multiplication. from multiplication, you start talking about algebra and all of that. So once you've gotten the understanding of the basics, you can now move into the more complex stuff. So that's the flow we are going to be going to. Then in our next class, we can now look at writing tests for maybe the token sale contract we wrote, or we can write a bank contract and test it as well. So whichever way the spirit leads. All right. Now, section 1, what is testing? I'll be doing reading and explaining. So I'll read what is here, then I'll explain it. So testing is the process of evaluating a system. So this is general definition of testing. Testing is a process of evaluating a system or its components to determine whether it meets specified requirements or expectations, right? So testing is not only applied to smart contracts. If an electrician comes to fix something in your house, after the whole connection and all of that, they'll have to test it, check all the lighting points, turn on the switch to be sure that everything is working as they expected. Similarly with automobile companies, when they finish building a car, they need to test drive it, test run it, they'll call, so some companies call drivers to move the car with high speed and see the performance at different miles per hour, stuff like that. So these are testing in different areas, not just coding and all. So testing is basically used to evaluate a system or the components of that system to ensure that it meets the specified requirement or expectations. The main goal of testing are to identify defects, verify functionality, and assess overall quality of the system. So when you're testing, you're checking if there's a problem, there's an error, because there's one adage in programming that say if it works at first, then it's not programming. It's supposed to, throw errors, unless maybe you're so good at that stuff, you've done it over and over again. You can just write the code once and everything works. But if it's something you're building for the first time, it's expected to, fail, you fix it, even if it works, it won't be efficient, then you try to optimize it. So testing, one of the major reasons why you test is to identify defects, which are errors, verify that the functionality works as expected, and also assess the overall quality of the system. All right. So section 2, we are looking at the categories of testing. Now we are now bringing it down to smart contract testing or testing in coding, programming generally. So there are a number of ways to test a smart contract on Starknet. There are unit testing, integration testing, end-to-end testing, force testing, and fork testing. There are other ones I didn't cover for the purpose of this class. There's something called invariant testing, but we are not covering that in this class. So you can do extra research on invariant testing. So let's look at unit testing. Unit test involves testing individual functions or components in isolation. So it's very focused. It's very focused and specific. Typically test one piece of functionality. It's fast to run. It helps locate issues quickly and simple to debug. And since it involves testing individual functions and its components, usually more because it constitutes the highest number of tests in a code. So I'm going to explain this one after the other. When you write a smart contract, for instance, you have something like a token, an ERC20 token contract. Now, when you write tests for the name alone, the name function, you write tests for the symbol function, you write tests for the total supply function. You see, you're testing each of these functions individually. Now, that is unit testing because you're testing each of the individual functions, right? Yeah, so those are unit testing. And imagine, let's say an ERC20 token has like 50 functions, which means you're going to write 50 tests for each of the functions. That is why it says it is, since it involves individual functions and its component, it's usually more, which means the tests are usually plenty. There are more tests. Imagine testing each of the functions, right? And it helps you locate issues quickly. So for integration tests, whereby you have to write a test that makes use of like 5 different functions, if that test is failing, you might not be able to detect the part of the test that is failing immediately. So you have to comment out some part of the test to actually get the function that is failing, because it is integration test. It involves you combining so many tests together. But unit testing, if you test maybe name function and it fails, you already know it's the name function that has issues, because you're not combining a lot of functions at the same time. It's just name function you're testing. So if it fails, you know that the problem is from the name function. Unlike when you're testing something like you want to test staking in let's say you write a staking contract and you want to test it. You know, you have to, first of all, mint token to someone, approve, transfer, then you stake. Now, if that test fails, you need to check if it's the approved part that is failing, or if it's the minting part that is failing, or if it's the staking itself that is failing. So unit testing enables you to identify defects or errors quickly and all of that. It's very fast to run. Since it doesn't involve interacting so many, it doesn't involve interacting with so many functions. It's very, very fast to run because you're running individual functions and all. So that is that. And it's very focused, because I'm focusing on, if I'm writing tests for name, symbol, and total supply, it's very focused. This is on name, this is on total supply, this is on symbol, this is on transfer, and all of that. So it's very, very focused. Now, unit testing can also, it might not be you testing individual functions. It might be you testing individual components. For instance, if you wrote a contract, like you have a contract, like a staking contract, and you also have a staking token, and you have a reward token, testing all the functions in the staking token can be regarded as unit testing. That, which means your unit testing can involve testing the staking token alone on itself, and testing the staking contract on its own is also regarded as a unit test. So it can be individual functions, it can be individual smart contract like components. They can all be regarded as unit testing. So the next type of testing we have is the integration test. So for integration test, it involves testing multiple components that are working together. For instance, when you want to test a stake function in your staking contract, you know that you need to first of all approve, you need to first of all mint token to the staker, to the person that is staking. Then you have to approve the smart contract to spend that token before calling the staking function. You see that in one test, you have interacted with 3 different functions from 2 different contracts. So integration test involves a test that deals with more than one component. Like I explained, the staking the staking function, you need to first mint the token to the staker, approve the staking contract to spend that token before calling the stake function. So that is an example of integration test, because you're doing 3 things, like you're interacting with 2 different smart contracts and 3 functions in one particular test. And if that test should fail, you need to detect whether it's the staking function or the approve function or the mint function that the problem is coming from. So that's one feature of integration test. Now, mocking can be done in integration tests. What is mocking? Let's say you wrote a smart contract that users let's say a staking contract, right? And that contract, users can stake any kind of token. But you want to test that contract. Will you now go and deploy the contract on chain, then now buy Ether or buy Stark token and test it on chain? No, you won't do that. What you do, you create a mock ERC20 token, which you're going to use to test that staking contract. So that mock ERC20 token will serve as a real ERC20 token if the contract is deployed on-chain. So that is why in integration tests, you have to mock. You have to create mock tokens. You call them test tokens or example tokens. So they are called mock. You can use things like mock contracts to test. And also mocking can also refer to in cases where, in things like Solidity, where you want to prank an address, for instance, you're writing a test and you want to make someone an owner. So you can prank that owner, like you make a particular address the owner to call a function. So you see what the performance and what it will look like. So we are going to do all of that here. Integration tests have fewer tests than unit tests. So if I'm doing integration tests, let's say I want to test my transfer function. If I want to transfer a token if I want to test transfer, it means I'll first of all mint a token to an address before transferring that token to another address. Now, if I mint a token to an address and I now transfer that token to another address, if the transfer test passed, do I still need to test mint? Please, I need to see your answer. If I'm testing transfer, and before I transferred, I've minted token to someone before transferring, and I check the balance of. If the transfer test passes, do I still need to test mint? I'm waiting. So I can choose not to test the mint because this is why. If I was able to transfer token to someone, it means the mint function worked. Yeah, if I was able to transfer token to someone, it means the mint function worked. So there's no need testing mint individually again when I've already used mint to mint token before transferring. I don't know if you understand. So, so that is what integration test does. For instance, if I want to test my staking contract and I want to test the stake function, if I approve a particular address, if I approve the smart contract to spend that token before staking, if that stake worked, I don't need to test approve again, because if the approve didn't work, the staking will fail. Because inside the staking function, I was making use of transfer from, and transfer from can only work if approved worked. I don't know if you guys are getting what I'm saying. Are you guys following? Yeah. So there are certain cases where you won't need, if I'm testing transfer function in my ERC20, I don't need to test mint separately again, because inside the transfer function, I will first mint to an address before I transfer to another address. I'll now check if the balance of the new address increased, and I'll also check if the balance of the address that did the transfer decreased. So if the transfer test worked, the mint worked too. There's no point testing mint separately again. That is an example of integration test. Integration testing, not unit testing. So that is it. So that's why they say integration tests have fewer tests, because in my stake, for instance, now, if I want to test my staking function, in that same test, I'll test mint, I'll test approve, because I'll have to mint to someone first. I'll have to approve the contract before I stake. And if that staking passed, that means mint and approve worked. So in that case, I've tested 3 functions in one test. So I won't need to test them separately again. I don't know if you're getting it. All right. So integration test also verifies interaction between different components of the system. So when we talk about different components or different parts of the system, we are referring to smart contracts. Like I have said, in your staking contract is an individual contract on its own, right? Your ERC20 contract is an individual contract on its own. But when you want to test your staking contract, you have to make use of ERC20 to test your staking. So you're testing two different parts of your system, which is your staking and the ERC20. That's what this one is saying. So it verifies the interaction between different parts of your smart contract, ERC20 and staking contracts, for example. I don't know if that is making sense. So your ERC20 is one contract, your staking contract is another contract. And by the time you're testing the staking, you're already testing mint and approve in ERC20 before testing the staking function in the staking contract. So these are two different parts of your system that are working together. So you're testing them at the same time. Integration tests are slow to run, true, because in integration tests, you're testing multiple components at the same time. So it can take some time to run, unlike unit tests that you're testing individual components. Now, integration test represents real world use case more closely. For instance, in integration test, if you want to test staking, if you want to test a staking contract, the normal real world use case of a staking contract is you're going to connect your wallet, right? When you click on stake, your wallet will pop up the first time for you to approve. Now, when you approve, the wallet will pop up the second time again for you to now sign the transaction for staking. Similarly, if you're writing tests for staking, you know you first mint the token to the person that is trying to stake. Then you approve the smart contract before you call the stake. This is a real world representation of what you would do if you were interacting with that smart contract using your front end. That is what this last line is saying. Integration tests represent real world usage more closely. All right. So let's proceed. Now we are looking at end-to-end tests. So end-to-end tests test the application from start to finish, simulating a real user's journey. It involves testing the complete system, including all components and interfaces. So a lot of times, end-to-end tests might also be regarded as integration tests if you're only dealing with the smart contract side of things. And in some cases, end-to-end tests might also refer to you testing the full system. For instance, let's say you have an API. Let's come to like the Web 2. Let's say you have an API, right? That API, a front end guy is calling that API. So that front end is going to write tests for the front end that's going to call that API, and get response from that API and update something on the front end and all of that. That is an example of end-to-end test for both the front end side of things and the back end side of things. But for smart contract side, end-to-end tests can refer to your integration test because you're testing the component from point A to point B. The same way you test your staking, you first mint, approve, and you stake, right? So that can also be regarded as end-to-end test. Then, if a front-end guy is interacting with your contract, the front-end person can also do an end-to-end test whereby they make a call to the smart contract, get response, do something on their front end, and they ensure that their test is passing. That can also be seen as end-to-end test. So end-to-end test, that's why I say it involves testing a complete system, including components and interfaces. Interfaces here means front end. That's the front end side of things that has to do with UI. Focuses on how the UI system integrates with smart contract, like I said, it is slower and more complex to set up than unit and integration tests. Yeah, that is if it has to do with the front end side of things. It is slower to set up and all of that because you have to like simulate how the front end will call the smart contract, get response, and all of that. So this is about end-to-end tests. But a lot of times, what you basically be doing almost all the time is unit testing and integration testing. There are rare cases where you make use of end-to-end tests. All right, force testing. So force testing, it aims at finding security vulnerability, crash points, and unexpected behaviors by feeding garbage inputs to the system. So inputs are generated automatically by a fuzzing tool rather than manually. It complements other testing like unit tests and integration tests as it focuses on edge cases and failure points. Now, what force testing majorly is focused on looking for errors. For instance, let's say in your smart contract, you have a function that is taking uint 8. And uint 8 has limit. There's a capacity. The highest number a uint 8 can take is 255. Now, you want to actually force test that function to see if it's going to fail if a higher number is passed to it, right? You're going to force test it and leave the force test to feed in different numbers at wide range. So that test is expected to fail if it's being given a uint 256 number, like a number that is larger than uint 8. These are cases where force tests are focused on. They are focusing on where to look for errors. Now, let me give you an example. A lot of times in your contract, you do things like uint 256, which is basically the highest number that ever exists and something like that. Have you ever thought of what if there's something like there's a higher number than uint 256 and that number is passed to that function? Will that function pass or will it fail? Especially when you're dealing with DeFi smart contracts. So these are places where force testing comes into play because you need to know the behavior of this function. If certain kind of numbers are given to it, how will it handle it? Will it break? Will it accept it and all of this? And most times you expect it to fail because if it doesn't fail, it's a problem. For instance, you're taking uint 8 and you give it uint 256. If it doesn't fail, it's a problem. So force testing is basically used to look for breaking points where this contract is going to break. And that is where it thrives. And a lot of times you use it to test, like you use it to test some of the functions you've tested before, like your unit testing and your integration test. So now we are looking at fork testing. For those of you that are from the Solidity background, you'll be familiar with this. So before I go into calling out the points, so most times there are some tests you want to do. It will require you to interact with a smart contract that is existing on chain. For instance, let's say you want to interact with Uniswap. Okay, let's leave Uniswap. Let's look. Uniswap is for Ethereum, the EVM side of things. Let's focus on a decentralized exchange that is on Starknet. Let's say you want to interact with something like Ekubo. Ekubo is a decentralized exchange on the Starknet ecosystem. Now, you're writing if you wrote a smart contract. Avenue is not a decentralized exchange. Avenue is a DEX aggregator. So what Avenue does is it interacts with all the decentralized exchanges. It's not a decentralized exchange in itself. All right. Yeah, it's just like 1 inch. Yes. So a Kubo, let's say you wrote a contract whereby, you wrote a contract that can interact with a Kubo's smart contract to swap two tokens, right? Now, if you want to test your contract to know how your contract works, you cannot test it by using normal unit test or integration test because you don't have a Kubo you don't have a Kubo code in your system. What you need to do, you need to fork mainnet or testnet. So by forking mainnet or testnet, it means you're creating a simulation in your local system that looks like the normal mainnet. And that simulation, it will interact with a Kubo smart contract the way it will interact with it normally if your smart contract was deployed on chain. So you're going to interact with it. And if your test pass, you will be sure that even if you deploy your smart contracts on chain, it's going to pass. It's going to work with the Kubo smart contract the way you expect it to work. So that is one of the use cases of fork testing when you want to do mainnet forking. In EVM side of things, we call it mainnet forking or testnet forking, where you fork mainnets. It's as if you have that smart contract on chain, you have it in your local environment and you're interacting with it the same way you're going to interact with it if your contract is deployed on chain. So that is it. So fork testing, it involves creating a duplicate or fork of a live production-like environment. You get what you are getting it now. So you're creating a fork. If you're forking a repo on GitHub, what are you doing? You're creating a clone of that repo into your own GitHub profile, right? That is the same thing mainnet forking is. When you fork mainnet, you're basically creating a clone of mainnet in your local system and you want to interact with that contract the same way you interact with it on chain. So that's it. So it allows developers to test changes without impacting the actual production system. So all the tests you do in your mainnet forking, it doesn't affect the main contract that is on chain. It's just a simulation. I don't know if you know what simulation is. It's just a simulation to see how it's going to interact with the contract if it was on chain. So it's a simulation. It doesn't affect the contract that is already deployed. It mirrors the real world conditions as closely as possible. Yes. So I've done mainnet forking a lot of times, even in the Starknet ecosystem when I was contributing to one project on Only Dust that involves me interacting with a Kubo and I think a Kubo and one other centralized exchange like that. I had to do mainnet forking to interact with their functions and all of that. Then on the EVM side of things, I've interacted what's it called, with Uniswap countless times. I can't even remember the number of times I've interacted with Uniswap. So you need mainnet forking a lot. Now, as a smart contract developer, let me mention this now that it came to mind. There are certain things you must know. If for instance, if you're applying for a role as a web developer, there are certain things you must know. You must know HTML. You must know CSS. You must know JavaScript, web developer. Then, before we now start talking about back-end role, when you now choose your back-end programming language. If you're applying for roles of front-end, you must know HTML, CSS, JavaScript before you talk about knowing, let's say, React, TypeScript, and all of that. Now, when it comes to smart contract development, there are certain things you must know like the back of your hand. Number one, you must know how ERC20 token works like the back of your hand. Even if you're sleeping, they wake you, you should be able to explain ERC20 token or ERC20 standard very well. You should know how ERC721 works. You should know about mainnet forking. Very, very important. You should know about things like, so on the EVM side of things, you should know about things like Crate 2 and all of that. Then generally, you should know about things like factory contract, how to create clones. Now, why I mention this is because mainnet forking is a prerequisite for you to be regarded as an actual smart contract or blockchain developer. If you don't know it, it's obvious you don't know what you're doing. So pay close attention. Although we are not going to be writing tests about it in this class, in this session and all. So it's a more comprehensive integration testing compared to just running tests in a local environment. Remember, normal integration tests and unit tests, you're just testing your smart contract locally. But you know that sometimes you must have heard things like, it's working in my system, but when you deploy it, it's no longer working. Things like that happen because sometimes live, when your code is on production, it behaves differently than when it was in your system and all of that. So mainnet forking is a more comprehensive integration compared to running tests in a local environment. So here it gives you clear picture of how it's going to work normally. It helps identify issues that may only arise in a real-world production-like setting before deployment. Yes. So there are some issues you might not face when you're not testing your smart contract normally, only when you're working on it in production. Like for instance, you might write your code and you test it, everything is working. But you know, if you're testing, if you're interacting with decentralized exchanges, there's something called timeout. There's timeout when you're swapping. So if your swap doesn't go through within a particular period of time, it's going to fail. It's going to revert with a timeout error or something like that. Now, how do you handle timeout error? These are cases where you need to, now if you're doing mainnet forking or if you're interacting with a smart contract on chain, you need to know how to handle some of these things. Because in your test, you might just write it and that's it. But on production, when there's timeout, your smart contract might not make room to handle timeout cases. And maybe you might have removed money from someone's wallet. And when it times out, you won't return it back to the person's wallet and something like that. So mainnet forking gives you a clear picture on how to handle real-world production setting and all of that. Another and a close example of timeout in Web 2. So let me explain it in Web 2 so you understand it. Let's say you build a system whereby so let's say you build a system whereby people fund their wallet, right? They fund their wallet, and from their wallet, they can transfer money to someone else. Now, you now initiate a transfer transaction. And you know, when you initiate a transfer transaction, you're going to deduct the money from the person's wallet before you tell Paystack, or sorry, yeah, you deduct it from the person's wallet before you tell Paystack to process, Paystack or any other payment gateway to process that money. Now, there's a possibility that that API request you make to Paystack can return with a failed response. Now, if it returns with a failed response, you have to create a webhook to handle that failed response, whereby if the response you receive is a failed response, you have to update that person's balance back. You have to add that money to that person's balance back. So similarly, in smart contracts, when you're interacting with smart contracts that are already deployed, you have to understand how that smart contract works, whereby if there's a timeout error or something, you have to capture it so that you handle it in your smart contract, so that you don't move someone money, and when there's timeout error, you don't return the person's money. They will drag you on Twitter. All right. And that's it. That's for pop testing. Now let's move over to the next guy. Somebody say, Casweeney, please let me come and be staying with you. Don't come and be staying with me. There's no space in my house. All right. So why test? Why do we test? So number one, you test to identify and fix bugs, right? There was a time I wrote a smart. Oh no, not me. I didn't write that smart contract. There was one project I was working on Only Dust during one of these OD hacks. So the person, they have already deployed that smart contract on testnet, and I was asked to write a particular test. But in the process of writing that test, because that test has to deal with another function, I was meant to test a particular function. But in the process of writing that test, and that test requires me to interact with one other function, I now discovered that there was a bug in that function. And this, they didn't even figure out the bug. They didn't point it out. And this is one of the importance of testing. So it helps you identify and fix bugs. Testing helps you identify and resolve security vulnerability. I hope you understand that not all bugs have to do with security vulnerability. Some bugs might just be, okay, let's say there's an error in spelling or something, but there are some bugs that are actually security vulnerability, whereby it will involve you losing money. You heard about hacks and all of that. So there are some bugs that doesn't have to do with security vulnerability, and there are some bugs that involve security vulnerability. So testing helps you identify and resolve security vulnerabilities and all of that. So, and one of the reasons why I told you guys that Cairo is easier than Solidity. I will say it, and I can defend it. If you know how to write Cairo, everything is almost the same. And since Cairo is a language that's borrowed from Rust, right? The compiler will save you from doing so many blunders, unless you intentionally want to write rubbish code. But you see Solidity, you might write the best code in this life. They will still hack it. They will still move funds. They will still use inline assembly, manipulate with your EVM storage and move your money. Solidity is what gave rise to security researchers and auditors. It was in the era of Solidity that the field of I'm a security researcher, I'm a smart contract auditor, it was Solidity that gave rise to things like that because of how the language is. If it wasn't for Solidity, security researchers and auditors will not eat food. When you see Cairo and things like Rust, it will help you, like, it's a language that helps you save you from yourself and all of that. So, but I'm not bashing Solidity before they'll go and drag me on Twitter, because that's the place that drag people these days. So, like I wrote here, money is involved, right? The moment you become a blockchain developer, every code you're writing is dealing with money. The moment you're a blockchain developer, every code you're writing is dealing with funds. From protocol level, there's Cairo audit and all of that. Yeah, there's Cairo audit. But you notice it's not as loud Cairo auditing is not as loud as Solidity auditing. Solidity auditing is loud, very, very loud, because you will definitely see errors, you will see bugs. But Cairo auditing is not very loud, unless there are critical manipulations in numbers and all of that. But it's not as loud as Solidity. So as I was saying, when you move into blockchain development, from every code you write is dealing with money. It's either you're writing something that is dealing with ERC20 token, which is the center of DeFi. DeFi is centered on ERC20 token. So you need to understand ERC20 token like the back of your hand for you to do anything DeFi, which is money. Now, when you come to areas of NFTs, NFTs are still money because the people buy and sell NFTs, right? So then when you want to start dealing with things like games and all of that, you can make games that are for fun and all those things that people don't have to, do all of this. But if people are signing transaction, which means they have to sign transaction to play games and all of that, you can write a rubbish code that when someone wants to sign a transaction, it will drain the person's wallet. You're still dealing with money. So with blockchain development, as a blockchain developer, most of the code you're writing, you're dealing with money. So you have to be very, very careful, and you have to embrace testing and love it. Now, the third reason why you write tests is to verify that your smart contract works the way you want it to work. For instance, if you write a function that adds 1 plus 1, if you test 1 plus 1, you expect it to be 2. So if you test 1 plus 1 and you put 3 and the test passed, bro, you have to check your code because it's not working as you expect it to work. Then ensure correctness and reliability of your smart contract. Yeah, when you test your smart contract very well and everything passes, you can hit your chest and say everything is working as it should. For instance, you know the battle that always exists between front-end engineers and back-end engineers, where I'm more of a back-end engineer. That's why I don't like front-end. You finish writing your code, you test everything is working perfectly well. You give API to the front-end guy. Out of laziness, the front-end will not want to do the real work. Any small error they face, they'll tell you it's from the back end. But I've tested my code. Everything is working as it should. So I don't even need to look my code. I'll tell you, bro, it is from you, the front-end guy. Everything is working as expected. That is one of the things testing does. It makes you know that your code is reliable, irrespective of what anybody say, whether front-end guy or anybody. Let the person go and do their due diligence and find where the problem is coming from their front end. It's not a back end issue. Similarly, it's not a smart contract issue. I've had a case where I wrote smart contract, tested it. The front end guy was interacting. And next thing the guy was like, the error is from the smart contract. I went and looked at my tests, checked everything, I ran everything is working. I said, bro, this thing is not from the smart contract, it's from your end. And the guy was still arguing, and I said, okay, let me see your code because I write front end too. And I looked at the code and I told him, this is how you should have done it. This is how you should have done it. At the end of the day, it was a front end issue. So most front end guys, they just don't like to stress themselves. They want everything to be spoon-fed. So that's by the way. Now, testing builds confidence as a developer. When you write your test and everything is working, there's this confidence you have. Your shoulder will go up, like you feel joyful. Like when your tests are passing, the joy you get is more than when your code is compiling. So you stay joyful. Sometimes you can just take yourself out on a treat because these things are your test is passing. I have to move very fast now because we have to write tests too. Tools for testing. We are basically going to be using Starknet Foundry. So Starknet Foundry, for those of you that are coming from the Solidity background that knows about Foundry, So there's also Starknet Foundry, which is the same guy, but for the Starknet ecosystem. So it gives you a lot of cheat codes out of the box. For instance, for Foundry, you have things like prank, where you want to prank someone to be the one to call a function. On the Starknet Foundry too, you have something also, cheat codes like that, that enables you to prank an address and make the address to be the one calling the function. So now we are done with all the whole talk. We want to now move into the actual coding. So this is what we are going to do. First of all, this is how we are going to start our testing. I'm going to show you how to write tests for a Cairo program, which is not a smart contract, a normal Cairo program. I'm also going to show you how to write tests for a basic smart contract. This is for everybody to understand, so that we don't just go. You see, composability and component was a bit confusing because there's no easier way to teach composability or components. There's no easier way. That is how complex it is. So you have to embrace it that way. Then when you now take time to read and practice it, you understand it better. But for things like tests, we can go with the smaller ones. You understand it on the basic level before we go into the more complex ones. So that is how we are going to flow on this class. All right. So before we proceed, right, do you have questions? Ask questions before we proceed. Okay. So at what point is it preferable to use unit testing over integration test and vice versa? All right. So where I work at the moment, right? The way we write tests, we test individual functions. That's how we test. So this is what we do. For every function, we have like 8 tests for each function. So we do both unit tests and integration tests interchangeably. For instance, if I have a staking contract and ERC20 contract, we are going to write tests for all the functions in the ERC20 contract. Yes, we are going to write tests for all the functions in the ERC20 contract. And each of those tests is called a test tree. And each of those functions will have like 4, 5, 6, 7 tests, depending on the complexity of the function. If the function has a part where it's going to revert, we are going to test and expect it to revert. If it has a part where it's going to emit an event, we are going to test and expect it to emit an event. Then we are going to test it in where it works properly. You understand? Then we are going to test it and expect it to fail. Now, these are 4 tests in one function. Then if we want to now test the staking function, that's the stake function, we are going to still test that staking function using the ERC20 token. So we are going to mint, approve, and still stake inside that staking test. So inside that staking test, we are doing integration test. But when we are testing the ERC20 on its own, we are doing unit testing, because there's no how you're going to test a staking function without using an ERC20 contract. So that staking function is automatically an integration test. That one, it's not a unit testing, because you're going to use ERC20, you're going to mint, approve before staking. So by default, that one is integration test. But for the ERC20, you can test name, symbol, total supply, all those ones, they are unit testing because they are standalone. You can test them alone. But you cannot test transfer function alone, because for you to test transfer function, you have to first mint to somebody before transferring. So transfer function, you cannot test it alone. I don't know if it's making sense, Hamid. So who is the person raising hand? Just type. So that is how it is. So if you're testing, if you want to test a function that depends on another or other functions, there's no how you can do unit testing for it. You can just see testing that function as unit test because it depends on other functions or other smart contracts. Example is taking function. There's no how you want to test it alone. You have to mint approve before calling the staking function. Yeah, are you seeing my screen? There's something on my screen called less code. That's the only thing on my screen, so you should be able to see it. I'm just answering questions, yes. Yeah, we have not started coding yet. I'm just answering questions. All right, any more questions before we proceed? All right. So I'll take it that there's no more question. Let's fire down. We're about to fire down. So don't allow anybody to distract you. Okay. All right, let me exit this guy. I'm gonna minimize it. Oh, shit. All right. Yeah, this is our guy, right? So the first thing I'm going to do, I want to create, like I said, we are going to do three things. I'm going to create a simple test for a Cairo program. That's not a smart contract. You know, you can use Cairo to write smart contracts, and you can use Cairo to write a normal, like a normal code. The same way you use Rust to write normal backend or use JavaScript to write normal backend. You can use Cairo to build an application that is not a smart contract. That is where Cairo program comes in. So, but if you want to write smart contract, that one is now different. That's smart contract that runs on Starknet. So Cairo is a language that can be used as smart contract or can be used as a general purpose language. Same way, Rust can be used as a general purpose language. It can be used on Stellar or Solana chain for smart contracts. That is how Cairo is. Cairo can be used as a general purpose language, or it can be used as a smart contract language for Starknet. All right. So let's go. First thing first, I'm going to open my terminal on this guy. Open terminal. Right. Right. So I want to say scarp new what should I call this guy? What should I call this guy? Cairo. Okay, Cairo program. So we want to write a test for a Cairo program. So now look at this guy. You see that, sorry. You see that we have two options, Starknet Foundry. The moment you choose Starknet Foundry, it means you want to use Cairo for smart contracts. But when you go down and click on the Cairo test, it means you want to use Cairo to write a normal Cairo program. So that's the one I selected, the Cairo test, and I'll now click enter. So once I do that, I'm going to open this folder and I'll see Cairo program here, right? So I'll open it. So I'll just do code and this guy should open here. All right. So this is it. So let me zoom in. One, two, right? So I'm gonna get rid of, so pay attention. In your Starknet contract, you don't have main function. But in the normal Cairo program, you have your main function, which is the entry point of your program. The same way in Rust, your entry point for your Rust package is the main function. But if you're using Rust as a library, you don't need a main function. If you're using it as a smart contract for maybe Solana or Stellar, I don't think you need main function. I've not built on any of those. I've not built on any of those chains, right? So, but I don't think you will need a main function to enter into it. Yeah. So what we are going to do now, we are going to get rid of this guy. So we are going to create our FN main function, right? And this main function is going to return a uint 256 and this guy. So it's going to throw an error. So let's just put 6 here so that it doesn't throw an error. If you remove this 6, it will throw an error because it's expected to return something. So let's return 6 for now. So I'm going to create a function. I'll call this function public function. I'll call it add. And this function is going to take in two parameter left, which is AU256, and it's going to take right, which is also AU256, right? And this is also going to return AU256, right? So what we are basically doing here is we want to add two numbers together. So what I'll just do left, right, plus right. And that's what this function is doing. It's just returning two numbers, right? Now, let's write a test for it. So here, we don't have a separate test module. Like we don't have a separate test folder for this. Your test will be written inside the file. You just create a test module for it, which is mostly how we write tests in Rust, right? So what you just do, you write an attribute, call it CFG. This CFG means configure, or yeah, if I'm not mistaken. Then you say test inside this guy. Then you now create your module. You call it mode tests, and you open this module down here. Now, inside this module, you want to bring in everything that is outside this module so that you'll be able to access them. So you do use super colon. What do we want to bring? We want to bring in add because that's the function we want to test, right? Then you now create your test attribute. I say test. And inside here, you say function test addition, right? And you do this guy. You open this guy. So basically what you just want to do, you now say let results be equal to, right? Add, you're calling that add function, and you want to pass it two numbers. Let's say we pass 10, 10. So 10 plus 10 is expected to be 20. So we are going to say assert, right, that result is equal to 20. Else, you say something like wrong result. And that's all. That's all. That's all. So let me open my terminal now to run this test. This is basic test. This is for a Cairo program. This is not a smart contract. So we'll open this guy now. I'll say scarp test. Yeah, let's just test it to fail first. So scarp test. So scarp, the Cairo compiler takes a lot of time because so you see it's failed. Let's see what it's saying. Test failed. Blah blah blah. Wrong result. So you can see here that it's outputting wrong result, right? And the reason why you see it panicked with this thing is because we are using assert without a macro here, which means this stuff we wrote here is a felt. Felt is the default type of the Cairo VM. So this guy is felt. Now let's put 20 here and run it. You see that it passed. Now let me show you how to use byte array, which is normal string that is not felt. Now, the moment you add a macro here, you're already telling this guy that what you're expecting here is a string, not felt. So what you're going to use here is double quotes instead of single quotes. So for here now, this is now a string. It's not a felt. So let's run the test again. And it passed. Let's change it to 10 and see if there will be difference with what it imputed the other time. Yeah. So panic. Now you see that in this one now, it didn't return that number it returned when we used it. So pay attention to this. See that here, there was no number. It just say test addition panicked with wrong result. But when we use this guy and we use this guy, sorry, we use this guy, right? It's going to return and you're going to see like a number output. See this number, this is felt. This is felt. That is what it's telling you. So this guy now is a felt output. I'm thinking this felt is the same thing as this wrong result. This is the felt equivalent of this wrong result. Yeah, so that's it. So if we now use 20 back and it should pass. So you see, this is where we talk about expecting your contract to work as intended. 10 plus 10 is supposed to give you 20. If 10 plus 10 gives you any other thing, then this is not addition. So this is for a Cairo program. This is not a smart contract. This is very basic. I expect everyone to understand this. Now, so this is by the way, right? Let's move over to the next guy. So based on what we have here, the next stuff we are going to do, we are going to write a basic contract, which is a setter-getter contract, right? So let's quickly do that. I'm going to close this. Yeah. So I'm going to, oh, sorry, let me minimize this guy again. I'm going to open a terminal here again. Right. Increase it. So here I'm going to call it scarp new setter getter. So that's the name of the contract. So here now, I won't use watch. Here now, I won't use this Cairo test. I will use Starknet Foundry because here I want to create a smart contract. So I'll click the Starknet Foundry and it's going to initialize that guy for me. So I'm just going to do cd into setter underscore getter. And I'm now going to do code dot to open it with VS Code. All right, so here we go. All right. So let me increase the size. So in this guy now, this is our library. So I'll just clear this guy, right? I don't need this. So what we want to do, we want to write a contract that should be able to set a number and also be able to get that number from. So you write to storage and read from storage. That's the contract we are writing. That's the most basic contract you write in smart contract, a setter getter contract. So the first thing we are going to do, we are going to create our interface. Remember, you cannot, in Starknet, you cannot write a contract without creating an interface for it. So we do this guy, I will say Starknet, colon, interface, right? Now, to create an interface, we make use of traits, so a public traits, right? We are going to give it I, setter, getter, right? That works. So this should take in a generic. Yeah, I wanted to show you guys something. I just remembered. It just occurred. Let me look at the time. This, I don't know, Sarah, are we permitted to go beyond time? Because from what I'm saying, we might not be able to finish this class within time. So, but let me quickly show
Okay.
you guys something.
Yes, we can add additional like 30 minutes, finish say by 8:30.
All right, that's great. So I wanted to show you guys something. Let me just open this Cairo program quickly. For in case you didn't understand what I was explaining about generic the other time. So let me see if I can explain it with this guy now. It just occurred to me. Right. I don't know if I can do that. So watch. I don't know if I can do that though, but let's see. Let's see if we can use 10.5 here and 10.5 here. It's not going to work. The reason is because 10.5 is not in 256, right? Now let's see if we can make use of generic here. Let's say we have something like T here, and we have something like T here. Sorry, let me maximize this guy, right? And we have something like T here. Oh, yeah. So this is going to complain type annotation. This is not Rust. This is not Rust. This is not Rust. This is not Rust. Uh, this is not Rust. Never mind. Just forget what I was trying to do. I thought I could do it. If it was Rust, yeah, I would have been able to simulate that stuff I was talking about. So if it was Rust, I could have created this T plus T plus T. This is going to throw an error because the compiler doesn't know if the type I am passing is something that you can do addition or subtraction stuff on. So I can now do something like a trait bound or make that trait to implement a particular trait that can work with addition or subtraction. But I don't know if I can do that with Cairo. So in order not to take a lot of the time for this class, let's just let it go. So you can do research about it. So let's proceed. It was when I was about using this generic here that I remember that. So we are going to make use of a generic here, T contract state, right? And inside here, we are creating two functions. We are calling it fn set number. So we want to set a number and be able to like get a number. So since this guy is updating states, we are going to make use of ref self, and this is going to be the T contract states, right? And also it's going to take in the number we want to set, and the number is going to be a type of U256 256, right? All it does is set, right? Then the next one we're going to work with is the get number, fn get underscore number, right? And this one is not going to take in reference. So it's just going to take in self. And since it's reading from state, it's taking a snapshot, right? In Rust, this is called in Rust, this is called what is it called again? Yeah, in Rust, this is also called a reference. But here in Cairo, they have a keyword for reference directly. But in Rust, what you would have done here is an ampersand sign, which is a reference, something like that. But in Cairo, you call it snapshot, right? So you take a snapshot of this guy. So this was taking T contract state. And this one now, since it's reading from state, it's going to return a U256 because that's what we are writing to the state. And we're good. All right. So moving on to the actual contract. Now, here we are just going to do this guy. We are going to say Starknet : contracts, right? This is your entry point for a Starknet contract. It's not a main function. So you're now going to say mode. We are going to call this setter getter, and it will be like this. So since it's a contract, it's their basic prerequisite. A smart contract must have a storage, which we refer to as state. So you're gonna create this guy, call it storage, right? And inside the storage, you're going to create a struct, and that struct will be with the name storage. So this is like a reserved keyword. Am I correct? What's wrong? What's wrong? Okay, this compiler is not misbehaving me. The compiler is misbehaving me. It's taking a while. So this is it. Now, the only thing we want to do, we want to update the storage. Want to write to storage, want to read from the storage. So we need to create a state variable, that's a storage variable, where we can write and read from. So the name of that variable, we can call it number, and it will be of type U256, right? And that's all. So then the next thing, we now have to implement our interface, right? So we just call this, since we want the functions to be accessible externally, we have to flag it with the ABI encode attribute. So ABI in bracket embed underscore V0, right? This attribute tells the compiler that anything below it should be part of the bytecode of this smart contract. So we are now implementing setter getter implementation of the, so now let me show you something. Super, right? I setter getter. Now you now pass your contract state here, and you open this guy up here. So it's going to tell you that not all trade items are implemented, missing set number and get number. So it's telling you that you must implement all these functions. So what I'll just do, I'll just copy these guys in order not to waste time typing everything again. I'll just copy them here. Then give space here. So for this one, I will just open my curly braces. I'll remove the T here, and that's all. Then for this guy, I'll remove the curly braces here. I'll remove the T here. And since this guy is expected to return something, I'll just return any number so that I'll stop seeing that error. That's it. Now, let me show you something. You might not like this pattern, like using super all the time. So what you could just do, you can just say something like use create : right? I setter getter. So what we just did here, we just imported this I setter getter inside here. So there's no point using this guy again. All you just do is remove this super here, and you have the I-setter getter here straight up. So you don't need to use super all the time. Just you import it straight inside this module and you use it directly, and you're good. So what we want to do basically is we want to write to state. So to write to state, we want to say self dot write into, sorry, wait. Self dot number, right? Because it's this guy we want to write to. Now we now say dot write, and we now say we want to write number into it, which is the number we are getting from here. But remember, in the new Stack, before, in this previous Starknet version, you don't need to import anything to write. But now, I just discovered it while I was preparing for this class, that you need to import something. Like in our previous class, you have to import a storage pointer read access and storage pointer write access to be able to write to storage. So I'll just bring it from somewhere. I don't have that thing in my head, and my brain has a lot of things to carry that this thing. So you just bring this. Now you see that write is no longer there. I see that this one is not having these squiggly lines because we are making use of write. But this read is having these squiggly lines because we have not read from storage. So if I want to read from storage, all I just need to do is self dot number, right, dot read. And once I do this, this line is out because we have used this guy. So, and that's all. This is our setter getter. You set the storage, you read from storage, and that's all. So now we want to proceed to writing the test for this guy, which is where the main thing starts. So let's go to the test module. So you see that this one now, there's a dedicated test folder for it. It's not like the other one that you write your test in a separate module down. So I'm going here now. So this guy is making use of all this. So this is the default. I don't need this. So I'm going to get rid of it. And you see that here they are using setter getter, which is the name. But me, I'll be using create so that in case we decide to change the name of this package, this guy will not be throwing error, right? So I'm going to remove this guy. Get rid of it. So we have a function. For you to be able to interact with your smart contract, you need to deploy it first. So this function is a default function to deploy your contract in every test case. It's a helper function. So you deploy your contract, it's going to return a contract address for you. With that contract address, you can now use the interface to connect to the contract address before interacting with it. Remember, I mentioned you use interface for two things, for implementation and for interaction. So this is a case where we are using interface for interaction. For Solidity, it's the same interface you use. But for Cairo, you create an interface, the compiler creates a dispatcher for you. So it is that dispatcher you use for interaction, while you use the actual interface for implementation. All right. So that's just by the way. So what we are going to what we are going to do now, I'm going to get rid of all these tests or just leave it there so that we can build on them. So what we are going to do now is I need to, first of all, import my interface. So I'm going to say use create, use create, colon. I'm going to call this, what did I call this contract again? Use create. Is it this? What's the name of this contract? Sorry, star. Setter getter now. Why is it showing me test contract? Okay. Oh. This is calling this particular contract we are in. No, that's not what we need. We need so this create, and we want to get I setter getter. Okay, just let me use this, the guy in the star. Pick this guy. Use setter getter, colon, colon, I setter getter. Aha. So, but we don't want to make use of the I setter getter itself. We want to make use of the dispatcher. So I'm going to say I setter getter dispatcher. All right. Okay. And anytime you're making use of a dispatcher, you also have to import the dispatcher traits. So I'm going to also say I setter getter dispatcher traits. Yeah. Let me see how to do this guy normally with crates. Use crates. Right? Colon, colon. Let's see. I'm coming. It didn't work for crates. Okay. Let's just use this thing name. Let's just use the name. Yeah. All right. So we have imported this guy. So the first test we want to do, in this case, let me ask a question, guys. Let me see who will get this thing. In this case, which kind of test are we going to do? Is it a unit test or an integration test? Fastest person. Ah, okay, okay. Hmm. Well, if it's why do you say it's a unit test and why do you say it's an integration test? Type fast. Let me see your reasons. You need to set first so that you can use get. Very correct. Alfred is very correct. So it's an integration test. It's an integration test because you cannot test the set. You cannot test the set by itself. The only way you can know whether the set worked is by testing the get. How will you know the set is working? It's by testing the get. So if you set 10, you have to call get to ensure that the return value of get is 10. But it can also be unit testing if you want to refer to it as, it's one contract. It's a setter-getter contract. So you can look at it as the setter-getter contract is the component, which is unit. But if you want to look at it in function side of things, now it's integration because you're using two functions. You're not testing individual functions. You understand? But if you want to look at the unit from the smart contract side of things, from the components, then it's unit because you're just testing one smart contract. Yeah, so that's it. So the guys that said unit, they are not wrong, but the reason why they said the unit is what I wanted to know. And the guy said you're testing it individual functions, so that is wrong. So it would have been you're testing a single smart contract. That is when that unit is valid. So let's go. So we want to test, just say test setting and getting. So I'm going to get rid of this guy, this particular guy here. I don't need it. So now, before we interact with our contract, we need to deploy it first. And what you're going to pass here should be the name of your contract, which is this guy here. The name of this module is what you're passing here. So I'm going to copy this guy, which is setter getter. That is what I'm passing here. So you're telling it to deploy this particular contract. So it deploys it. Now I want to interact with it. I will now say the name of my contract is setter underscore getter, right? That's what I want to interact with. And the interface I'm using is this setter getter interface. So now watch. This contract address is what we are passing here. The reason why we are doing this is because, let me show you. If we call this setter getter address, what we are going to do here is contract address colon setter getter address. Are you seeing it? But if the name we are using here is the same with the name we are using here, let me show you. If what we are using here is the same with what is here, which is this, can you see this? This and this are the same. So there's no point repeating it. You can just use the shorthand by just removing this guy and leaving it like this. That is what we did there earlier. So that is why you see we just use contract address here. But normally what is here is this is the key, right? And this is the value. But if the key and the value are the same name, there's no point writing the key and writing the value. Just leave it like that and everything works. Does that make sense? So now we have gotten our setter getter contract. So let's now set this guy. We are now going to say setter getter dot set what's the name of the function? Dot set number, right? Dot set number, and we want to pass in 10, and we close this guy, right? So let's now get the number. Let number be equals to setter getter dot get number, right? So we just remove all of this. We don't need this. Remove all these guys. We don't need them. So all you just want to do, assert that number is equal to 10, or you say invalid, or you just say wrong number, right? So this stuff that you're seeing here is because of the Cairo compiler, right? I was looking for a fix for that. I've even updated my Rust compiler, but this stuff is still not going. But everything should work. Yeah. So let's check it out. So I just do is carb test. And this is expected to pass. Let me scroll up to the functions to the test so you see it well. You see that it's passing, right? Let's alter it. Let's make it 15 to see if it's going to pass or fail. You see that it's failing and it's returned with this failed and wrong number. So this is because what we set is not 15 and all. If we now set 15 now here, let's check again. You see that it now passed. So with this, we have tested our set number and our get number. Now, one way we would have, okay, let's see greater than or equal to, let's see greater than or equal to, right? Start test. It will pass for equal to now. It's supposed to pass for equal to. It should pass for equal to. Yeah, it should pass for equal to. So that's it. So now the only way, let me now give you guys the secret of testing every function individually. The only way to test certain function individually is to emit an event. Is to emit an event. Now, if we were emitting an event in that set number, we would have tested that set number individually, whereby we would test it and expect it to emit an event. And if that event was emitted, you will know that the function worked very well. So we wouldn't have depended on get number to be able to test set number. So emitting an event is one way to make sure that a function can be tested individually without depending on another function. Secret number one. All right, so that's that about this. We are done with this. Is there anybody that doesn't understand this test before we move to testing an ERC20 token? We have limited time, so we are going to move very, very fast. You guys understand it. Let's move to the next thing. All right. So I'm closing this. Yeah. So let's move to the next guy. So now I'm going to create, no. We are going to test that ERC20 token we created in the last class. So if you were not in the last class, it's for you. Remember the ERC20 token we created using OpenZeppelin components. That is what we are going to test now to be sure that those OpenZeppelin components we use are working. That's what we are going to test. So I'm going to open it. This is why it's not good to miss class. Or even if you miss, you have to catch up. So if you miss the other class, you might not follow here because you'll be doing a lot of catching up. All right. I'm going to test. So this particular session is going to have 2 assignments, right? I'm going to test 3 functions, and you're going to test 1. Then in the next session, we are going to do another test that will come with another assignment. So let me increase this, right? Yeah. So this is where, please guys, pay close attention. Was it this code? Okay, yeah, this is why I was doing test Ebuka Onebu, yeah. So this is the smart contract we wrote in the other class where I was teaching you guys how to make use of component, how to embed components. So I'm going to remove this Onebu components here because I don't need it. I'm going to remove this Onebu guy here, right? Where else did I use Onebu? All right, that was it. So, like I said, this contract, we made use of OpenZeppelin. So if you look, wait, what did I just do? Onebu components. I removed it. Okay, I'll remove this. Okay, I'll remove this. Yeah, this should be good. Yeah, it should be good, yeah. So I don't need all of those. So like I said, this is our ERC20. The only function we wrote here is this min function. Every other function, the name, the total supply, the transfer, the approve, all of them came from the ERC20 OpenZeppelin component. So let's test to actually see if the component we embedded, everything works perfectly. So now remember in our constructor, we initialize the contract and the name of the token is coding CAS and the symbol of the token is CDC, right? So let's go to our test. So in this test, I don't need this. Sorry. In this test, I don't need this. I don't need this. I don't need this either. So I'll just get rid of this. All right. So now let's play around. So we need an interface. But if you notice here, the only interface we created was this one that has mint. So we need an interface that contains all the ERC20 functions because we use interface for interaction. And for us to interact with this token, we need an interface that has all those functions, including this one. So I'm going to just create the interface inside this test, this thing. So I'm going to go and I'll copy that interface. Let me just do it here. I'll just say this guy, Starknet, : interface, right? I'll just call this, let me just call this public trait, right? I'll call this IERC20 plus mint. The reason why I'm calling it IERC20 plus mint is because the standard IERC20 interface doesn't have mint function. So I'm just adding this plus mint because this one now we need the mint function so that we can mint token. So that's the thing. So I'm going to copy the IERC20 methods and all, right? And paste it here. So these are the functions that makes up okay, I didn't pass in this guy. I'm supposed to pass in this T contract state, this generic. So you should work. My compiler takes time. Oh, did I spell something wrong with it? It's the same spelling now. Why is it taking time? Type not found. Are you high? So the compiler is taking a while. Why the compiler is taking time? Okay, it's fixed. Why the compiler is taking time? Let me bring in this other function signature in. So this is so that we can be able to interact with the mint function, right? So now we have this. So the first thing we are going to do is we want to test the constructor to know if the constructor actually is working. So this is a constructor. Remember, it's in our constructor that we are calling the initializer from the component. So we want to test to check if this coding class and this stuff is properly set, like it's properly initialized. Who can tell me the kind of test we are going to do here? What kind of test are we doing here? Hello? Ah, why do you say unit test? Why do you say unit test? I'm asking the person that say unit test. So let's proceed. So I'm going to call this test constructor. So please name your test so that the name corresponds with the function you're trying to test. I don't know if you understand, because it will help you to know where the actual function you're testing. So I call this test constructor, right? So the first thing we are going to do, we are going to deploy our contract, and the name of our contract is what? Let's copy it here. Test ERC20 is the name of our contract. So I'll copy it and bring it here, right? So the next thing, after testing this guy, we need to like connect this contract with the dispatcher. So we are going to call this ERC20 underscore token. And the dispatcher we need here is not this hi hello world. What we need is this guy. So I'm going to say so this is the dispatcher we need. Will this, yeah, it works. So because we have the interface here, we don't need to import the dispatcher again. We can access the dispatcher directly because the interface is here. So once we do that, we have the dispatcher and we are using this guy passing the contract address here, right? So I'm gonna get rid of this guy. So the first thing we want to do, first things first. So now we have deployed. Remember, it is inside the constructor that we are setting this guy. So we are not passing any constructor argument. So what we now expect to do, we now say, let name be equal to ERC20 underscore token dot name. Now, guys, you notice that there is no name function here, but we are calling name. If there is no name, why is this guy not throwing an error? Can anybody tell me why this name is not throwing an error? We don't have constructor argument in this one. We are not doing the example. You go and research about it. There's no time. you go and research about it. If you remember the way in your math class, your teacher will teach you very simple example, right? Simple example. The classwork will be harder than the example the teacher taught you. The assignment will be even harder than the classwork. Then when you come to exam, it will look like something the teacher have never taught you before. That is the same thing I'm doing. So the example, the teaching is simple. Any other thing, you go and research it yourself. The reason why it's important to do that, so that you learn how to learn on your own. So that you're not spoon-fed everything, right? You learn how to learn. Yeah. Yeah, let me see the response. We have the name in the interface. No, that's not true. Even if you have the name in the interface, okay, for instance, let me do something. Let me create an interface called name underscore x, right? Or yeah, let's call a function name underscore x and see if it's going to work. Name underscore x. So if we call, let me run this test and see. This is expected to fail. This should fail. It should revert on that line. So let me do something. Let me copy this assert. Assert that, right? Name is equal to, let's get what we used there. It's equal to coding cast. Else you say wrong token name. All right. So let's get rid of all these guys. Yeah, let's get rid of all these guys. So let's see if it's going to work. You know, we have namex in our interface, right? And it didn't throw error here because namex is in the interface. But let's run the test and see. So now you're getting it. Namex is not in the component. It's not part of what we embedded, but let's be sure. Yeah, like seeing is believing. Let's see. if it's going to this compiler takes a while, so we should wait for it. This guy is taking so much time. So, and one of the reasons why it's taking this time is because it will deploy first and all of that. So it's done compiling. Let's see if it's going to pass. Scap. Please, fast. All right, we got the failure here. Entry point selector, this not found. Can you see this? Can you see this error? Entry point selector, this not found in contract because namex doesn't exist in that contract. You feel it, right? So let's now remove that namex and use name and see if it's going to work. Scap eats memory, like it eats a lot of memory. I really wish they can improve this whole stuff, but then again, you know, this is some crazy abstraction. So they have to like look for a way to make these things work. So it's taking a lot of time though, but it's expected to pass because name is in the component, and this is exactly what we used. Now you see that we are testing constructor, but we are not directly testing constructor. What we are testing is the name function. So this is more like an integration test, but you can still call it a unit testing. So, well, because we are deploying, and for you to test the constructor, you have to test the name and the symbol of the token. That is how you test the constructor. But this is basically, you're not actually integrating anything. You're not like doing an actual interaction where you're interacting with this. So I can still call this a unit test per se. So it's still basically a unit test. Yeah. Whoa, this guy is taking a lot of time. So while it's taking time, let me just be writing for symbol. Let symbol be equal to ERC ERC 20. Oh my God. What is wrong with my fingers? ERC 20 underscore token dot symbol, right? So we are going to be check that the symbol is actually, assert that symbol is actually, let's pick the symbol we used here. Assert that the symbol is actually CDC. So it's actually CDC. You see that the test passed. So you say wrong token symbol, right? And that's it. So if we run it again, maybe this one will take 5 hours to run. But you guys get the gist, right? And if you look at this code, there's no symbol here. So the symbol came in based on this component that we embedded, this mixing we embedded. And you know, the reason why we have access to it is because of we added ABI embed 0 on top of this guy. This guy is different from this guy. It is inside this internal implementation that we were able to access the initializer and the mint. But every other thing, that's the token, the symbol, the name, the total supply, the transfer, the approve, they are in this embedding, this line here. That's why we added this embed V0. Without this embed V0, we won't be able to access the name and all of that. So that's the first test. So let's move over to the second test we want to write. So the second test we want to write, we want to test total supply. Now, who can tell me testing of total supply, is it a unit test or an integration test? Why is it an integration test? Mojid, why is it a unit test? It is your why I'm interested in. If you say it's integration, why? If you say unit, why? I'm waiting, no. Answer now, guys. It comprises of many functions. That is why it is integration. No, like I need to tell me unit test because it's one contract. Very correct. So you can refer to it as unit test because it's one contract. But if you want to refer to it as integration test, why would it be an integration test? Ebuka, the answer you drop is not very correct. I need you to give me specifics. Integration test because you need to meet before check. Very correct. Yeah, that's what I was expecting. So I'm going to do a lot of repetition here. So I'm going to pick these two guys because I'm using them. I'll just drop them here, right? So once we put those guys there, what I'm going to do, I'll just say, no, I don't even need to do, I'll just say, ERC20 token. So first things first, let me just say mint amount. Let mint underscore amount is equal to 1,000. 1,000. Yes, 1,000 times. Okay, yeah. Let me get the token decimal. Let me get the token decimal. So I'll now say let's decimal be equals to, watch what I'm trying to do, equals to as 20, oh shit, Control Z. This dot decimal, right? Right. So I'll now say 1,000 times decimal to give you that E18, right? Times decimal. Yeah. No. They call it decimals, not decimal, times decimal. So let's see if this works. Are you working? Are you working? Is there no token decimal in my list? Yes, there's decimal now. Ha. Now, the reason why this guy is complaining, who can tell me why? Who can tell me why this thing is throwing error? Let me see. Somebody that is fast. Why is throwing error? Fast. I'm waiting. When you say doesn't fit the range, how do you mean? I want to be sure you know what you mean by it doesn't fit the range. Yep, I'm waiting. Ah, you're taking too much time. No, I need to know. Ah, Alfred, you guys are not getting it. Like, tell me. Well, you didn't get it. I'm moving on. I'm moving on. Should I move on? Well. Let me move on. Let's see. This should work. This should work now. What's happening here? This should work. Ah, wait, I'm coming. Let me check something. Mhm. No, now we have turned this to dot into now. What are you saying? Okay, I'm coming. Let me do something quickly. Uh, why? But this is supposed to work. What is happening? Is it the compiler problem? Yeah, the thing is, this is U in 256 and decimal returns U in 8. So we are trying to convert this guy to like U in 256 or something. Wait, are we supposed to do try into? Are we supposed to do try into? No, now into should work. Decimal returns, just a moment. Decimal returns U8. Okay, let's do try into. Try into, right? Here we are going to do dot unwrap or wrap. Hope my compiler is not joking with me. Okay, I'm coming. Just a moment. Let's do let mint amount be equals to 1_u256, right? So I'll now say mint amount. Yeah, let's see. Dot into. What is happening? This guy is This guy is doing something else. I've done this thing before. This thing is not. No. What's happening here? I'm looking at, so I'm checking my code. I'm checking my code that I've written before. If into doesn't work, then try into should work. And since you're doing try into, which returns okay or error, you need to unwrap it, right? You need to unwrap it. Whoa. I will not spend time on this thing. Please, let's move ahead. Sorry. So What I'll just do, let's move with the mint amount. Let's forget about the decimal, beg. I don't want to stress on this thing. So can figure that one out better. So I'll just say, let's remove this guy. So mint amount is just 1,000, right? So I think I'm having a very strong feeling that my compiler is what is causing this problem. See, this guy is still throwing error here. Unused variable. Unused variable is not supposed to throw an error. Can you imagine? So let's just proceed. So I'm going to do ERC20 underscore token dot mint, and we want to mint this mint amount. So let's look at our mint function. Our mint function is only taking in, okay, it's taking the recipient address and it's taking the amount. So let's construct an address that we are going to use to be the recipient address. So I'm going to use this. I'll just say this is going to be our recipient address, which means I'm going to import something. So sorry, guys, some of the things I'm using might be deprecated, but I don't know. I don't know the updated version on the current Cairo stuff. So this is the stuff I just imported, and that is what I am using here, right? So I'm just creating a dummy address. The same way in your Foundry, you have something like make address and you pass in something to make a dummy address. So this is how you make a dummy address. So I want to mint to this token recipient, right? And I want to mint this mint amount to this person. So once I do this, I can now say, I can just say, let total supply, you know, the total supply increase when you mint. Let total supply be equals to ERC20 underscore token dot total. Let me see the name we called it. The total underscore supply, yeah. So the total supply, right? So what we just need to do is assert that total underscore supply is equal to the mint underscore amount, right? Else you're going to say wrong supply. Yeah. So, and you know that inside this test, we can still test balance of. Do you guys know we can test balance of inside this test at the same time? We can just check the balance of the recipient to see if the balance increased, right? Yeah, we can test balance of here as well. So let me just use one stone to kill two birds. So I can just say, I can do something here, say, let receive balance before mint be equal to this same guy, right? Dot balance underscore of the token recipient here, right? And after we mint, we now say, let balance after mint be equals to balance of that same guy, right? Pick it up, balance of the same guy. Sorry. So now we have the balance of, we have total supply. So we can also assert here that, balance before mint is equal to 0, right? Wrong balance before. Now, one of the reasons why we use assert with macro is because felt has limits of the number of words you can use inside. So if you want to use long description, it's better to use this other one where you're making use of strings. So wrong balance before mint. I hope this is not above the felt accepted words. Then we can say assert that balance after mint. Balance after mint is equal to total supply. The balance after mint should be equal to total supply. And also balance after mint should be equal to mint amount. So we are having a lot of assert here. So you can call this wrong balance after mint, wrong balance after mint. I think this might be the last function we will write.
Yes.
Now there's some, yes?
Sorry, we should start rounding up. We have like about 4 minutes.
Yeah, this is the last function we are writing. So total supply. So let me quickly test it. So there's something about this compiler. Anytime this thing is not showing blue here, it looks like this guy is having, why is this thing still showing error here? It shouldn't be showing error again now. This compiler is slow. So let me do scarp test. So I expect it to pass. Let's see. This test alone might take up the remaining 3 minutes that we have. So let's wait for it. Let's wait for it. Let's wait for it. So while we are waiting for this test, guys, hope you guys are following. Hope this is simple. It's not that hard now, right? You see, testing is easier than components. Guys, let me know. It's straightforward now. It's sweet. It's not as complicated as composability and components, right? You can make use of the chat. Yeah. Yeah, this one is very straightforward. It's not that hard. There's something I would have loved to show you guys, but we are rounding up. So maybe in our next class, so maybe in our next class, we are going to look at how to prank an address where we start making use of start cheat caller, end cheat caller, and all of that. So that's what we are going to start with. So we are going to, there's no point giving you the assignment again. Maybe, so the assignment and everything will just come in the next class. Yeah, because I didn't do any of the approve function. If I've done approve function, I would have asked you guys to test the transfer function of an ERC20 token. But since I didn't do approve, so there's no need for the assignment. You guys should just practice. You can practice the transfer and the approve as well, but there's no time again for that. See, the test is taking a while. Let's just wait for it. The compiler is still throwing me error here. I don't know why. Why is it still throwing error? Unused variable. How? This is something Starknet they need to really work on this. Because if you're not patient enough, whoa, you might break your laptop before your test runs or your compiler does the needful. And imagine if this test fails now. That means you're now going to look for the problem, fix it, and now wait for the test again this long before it runs and all of that. So yeah, this is not really encouraging. But then again, it's a work in progress. So yeah, while we wait for this guy, questions. Yeah, if you have any question, we can be talking about it before. You see, that error is out. The error is no longer there. Something that took up to an hour, a minute or 2 minutes before the error was out. So it's telling me that this is no longer, this is, I said it, this is deprecated. This stuff I used there is deprecated. I don't know the new one. So maybe I'll check for the new way of doing this. But this was how we were doing it before. Yeah. I hope this thing doesn't throw an error because there's no time. It's already 8:30. We have used 3 minutes to wait for Scar to compile and run the test. So hi Sarah. So we are done. We are just waiting for the test to run.
Okay.
And yeah,
All right.
let them see the out of what we did. If the test fails, well, you guys will go and fix it yourself, well, because there's no time to fix it on this call. Oh my goodness. Okay. Okay. Yeah, 4 minutes in. Another reason why this might be taking a lot of time. Okay. Yeah. So entry point not found. Which of them? Is it balance of entry point not found in contract? Which of them? Is it balance of? Is it total supply? Which of them? We have total supply, we have balance of. So which of them? Total supply is there. Sorry. Balance of is there. Which of them? Data entry points, test total supply. Which of the entry points? Is it the mint? Which of them? So recipient amounts is now you guys are seeing that stuff I was talking about. Now, this error we don't know the exact place where it's coming from because it's an integration test. We are using balance of total supply and mint, so we don't know where it's coming from. But then again, we'll continue in our next class. Thank you so much, guys. And yeah, and that's it. So
You wanted to say something?
yeah, so that's it. I wanted to call you.
Okay. All right. Thank you so much, Casweeney, for your time and for the thorough explanation. Yes. Apologies, guys, for the extension of the time. It was much needed. So, we've actually covered what we were supposed to also do on Thursday according to the curriculum. But I guess, Casweeney, we have something else to walk you through on Thursday. Yeah, so we might not even exceed 2 hours on Thursday. So guys, I don't know if you have questions before we close the call today. Are there any questions? For anyone that has complaints as regards week 3 homework grades, your tutor is not done grading, so that's why some some of your grades have not reflected yet. I think she said by tomorrow EOD is going to be ready. Yes, we're also planning to have an extra session next week. Next week is for front end. So we're planning to have an extra session on Wednesday. Yes, next week, Wednesday. So where we have all tutors available on the call to answer any questions that you might have. So this is not us coming with a structure or a curriculum. It's just for you. All the tutors are available on the call. If you have blockers or there are assignments that you've been given and you've not been able to solve them, or you have any blockers at all, or it might even be projects, probably be project idea or something, because after next week, after week 6, we have so no, next week is week 7. After week 7, we have week 8 and 9. which is the project phase. So you guys should start thinking about your project idea already, and you can start forming your teams if you want to act with a team, or you can also decide to go solo, right? Okay, so that's about that. Yeah, so if there are no questions, I guess it's time for us to say good night and see you on Thursday, same time. Please, you guys should try as much as possible to come on time so that we can start as soon as possible. Thank you so much, Casweeney, once again for your time and for the breakdown. Yes, and thank you guys too for joining today. See you guys next session on Thursday. Have a great night.
Bye, guys.
Bye.